Desmos directly accepts function notation as well. So let's say we have a function. We could just make that f of x equals x plus 3x squared. And that'll save that function for us. And if we ever want to do anything with it down the line, f of x plus 2, if we add 2 to it, or if we want to solve for, let's say, f of x plus 2. So we could see all those differences there. We could perhaps change that to a and play around with that value, see what it does to the graph over there, shifting horizontally. So it's nice for visualization purposes. Now, obviously, at the most basic, we can solve functions. So let's take a look at a couple of examples. So over here, that's the most complicated ones. We're going to start with f of x equals 3 raised to the x minus 1. So here's 3 raised to the x minus 1. And then we're being asked for f of 4, which is 27. So f of 4 is 27, or b. And of course, linear functions, simple as well. I'll just change this function to parentheses x minus 1. And again, they asked for f of 4, which in this case ends up being, as we see, 6. Now, something like this, h of x is 2 to the x. What's h of 5 minus h of 3? Yeah, we could plug 5 in, solve that, plug 3 in, solve that, and subtract, or we could just let Desmos do all the heavy lifting. So we can just start by putting in our equation. H of x is going to be 2 raised to the x. And then all we have to do is just h of 5 minus h of 3. And Desmos does all the work for us, right? So there it is, h of 5 minus h of 3 equals 24, which is answer choice C. Now we can go back to these more complicated problems to kind of give you an example of how powerful Desmos can be, right? Notice all these different variables. The function f is defined by f of r equals r minus 1, and then we got r plus 2 squared. I'm just going to use x for now because whatever's in the parentheses is our input. So we could do this as f of x equals, and that's going to be x minus 1, and that's going to be x plus 2, I think it was. Yep, x plus 2 squared. And we accidentally created a backwards parentheses there. There's our function. And then we want f of h minus 5 to equal 0, where h is a constant. So h is a constant. Let's create a slider for it. I'm just going to arbitrarily call it 5 for now. And we want f of h minus 5 to equal 0. So it's currently negative 4. And we can play around with that as h gets bigger. Oh, we saw 0 pop up real quick there. H is 6, and f of h minus 5 is 0. So that's actually a possible solution. And again, we could have just played around, keep sliding around as we get closer to 0. There's 1, 0. And notice over here is another 0. So either 3 or 6 would have been acceptable solutions in this case. Now let's try one more. So over in this next example, we have f of x equals x squared plus bx. So let's type that in. F of x equals x squared plus bx, and we'll create that slider for b to figure out what b needs to ultimately be. And then we got 3x squared minus 9x. So g of x equals 3x squared minus 9x. So we have our two functions. And what's this question asking for? So it says f of x times g of x equals 3x to the 4th minus 8x cubed minus 3x squared. What's the value of b? So let's first get that graph to figure out what we're ultimately trying to get for. So again, that is 3x to the 4th, 3x raised to the 4th minus, and we've got 8x cubed, 8x raised to the 3rd minus, finally, we have 3x squared, 3x. So this purple graph is what we ultimately want this all to look like, right? We want f of x times g of x to give us that purple graph. So now what we can do is just do f of x times g of x. And that's going to be this black line over here. I'm going to change that just to make the color easier to tell apart. Let's go with orange, sticks apart. So we want the orange graph to basically overlap the purple graph. So now what we can do is just hide the green and red because it's really just these two that we care about, then play around with our values of b until we overlap. So, okay, that's not getting closer. And here we are getting a little bit closer, and they're pretty close to overlapping. What we want to do is zoom in just to make sure we're perfectly there. So we can go to 0.3, and we know that's not quite there. 0.4 is off as well. So now we got to play around with our slider a little bit. So we can do from 0 to, let's call it 0.5 to get a better kind of idea. 0 to 0.5 to get a better kind of idea of what's going on here. So we can get closer and closer and closer. And that is about where we overlap 0.335 and up at 0.33. Let's zoom in. And it's a little off over there, so we can just go a little bit more. And there, 0.333 gives us an exact overlap. So B is 0.333 or 1/3. And of course, you could always just check that in your calculator after the fact, right? Just graph x squared plus 0.333x and g of x equals 3x squared minus 9x, and then just try it again, make sure you get the same thing. Or you could FOIL those two together and see what you end up getting there and make sure it matches up with 3x to the 4th minus 8x cubed minus 3x squared. So yeah, lots we can do with functions.